So chapter 15.2 in the application section for foundation starts with a recap on the formula that we just used throughout the skill section of 15.2. So the volume of a prism is equal to the area of the cross section multiplied by the length. It then goes into specific prisms in the exercise book. However, if you use the method that we used earlier, you don't need to remember them, you just need this. Okay. It then goes into the mass is equal to the volume and multiplied by the density. That might be involved in a question where you calculate the volume, then you calculate the mass of an object, for example. In that case, you'd be given the density to multiply it by, and so on. We then have some conversions. So 1 meter cubed is equal to 1 million centimeters cubed. So that's just 2 volumes. And then we have a measure in litres, which is equal to 1,000 litres. So 1 metre cubed is equal to 1 million centimetres cubed, which is equal to 1,000 litres. Okay, and 1 litre is equal to 1,000 centimetres cubed. So if you want to convert between those ones, then that's how you do them. Example 1 on the application section of 15.2, you're given a net for a 3D shape. So our 3D shape has been unfolded, and this is the net that is given us. So these are all the faces of our net, of our 3D shape, sorry. So on here, we need to decide when we fold it back up again, what type of shape is it going to make? So I can see that we have a triangle here and a triangle here. They're both right angles and they're both identical. So I would expect these to be our cross section. Okay, so we're going to have the same face on either side of our shape. So if we fold it back up, we can see that this 4 centimeters here is going to match up with this 4 centimeters here. That will work. This 3 centimeters is going to match up with this 3 centimeters. That will also work. This 8 centimeters will match up with this one, and so on. Okay, so we know that if we fold along all these lines, that's the shape we're going to make. Okay, so if we draw that all in, so if we join those all up, we have to use our we have to visualize this, and then I would always draw a sketch of what that's going to look like. So this is one that I've drawn, and that's what our 3D prism is. So we've got a triangular prism for this question. Okay, we need to decide which sides are going to correspond to what from the net. So this bottom one here, I know that my right angle is there. So my right angle is going to be there on that one. So I know that this 4 centimeters is my bottom side. Okay. The other side of my right angle has the 3. So this other side of that right angle there is going to be 3 centimeters. This slanted height here is going to be 5 centimeters because that's our other side there. And then our length is going to be 8 centimeters. Okay. So that's the length of our shape. Right, okay. So we then highlight what our cross section is. So we've already talked about that the cross section is the same throughout. So that triangle appears on both ends. It is the same throughout the shape. We then have our cross section to work with. So we know that this part, so our height is 3 centimeters. We know that our base is 4 centimeters, and this side here is going to be 5 centimeters. Okay. We need to find the area. So the area of our triangle is going to be half base multiplied by height. However, it might be a bit confusing between which height we're going to use. So we're going to use our perpendicular height. So the height from the base all the way up to the top is just 3 centimeters. This is our slanted height. We're not interested in that one. We don't use that. So a half multiplied by our our base multiplied by our perpendicular height, which is 3. So we've got half multiplied by 4, which is 2, multiplied by 3, which is 6. So 6 centimeters squared. So be careful with your perpendicular heights. Right, so our volume, so moving back to here, volume of a prism is equal to the area of our cross section multiplied by our length. Okay, seen that plenty of times. So the area of our cross section is 6, so that's our triangle over there, multiplied by our length, which is 8. So that face is projected back by 8 centimetres. So our final answer is 48 centimetres squared. Sorry, centimetres cubed, because we're dealing with volume now. And that is the volume of that that net would make. Example 2 describes Jessica's cylindrical vase. The vase has a radius of 4 centimetres and a height of 15 centimetres. Okay, so on here I have drawn a cylinder. So a cylinder is a prism with a cross section that is a circle. We showed that from earlier. And we know that the radius of this top face is 4. So radius is from the centre all the way out to the circumference, which is 4 centimetres. Okay. We also know that the vase has a height of 15 centimetres. So we have enough information there to calculate our volume. Okay, so it's asking about the volume, so we're going to have to calculate the volume of this to then work out our answer later on. Okay, so the cross section for this one, as we've just said, is this circle on the top, so that's this circle here. Okay, let's mark on our radius. So we've got from the centre to the circumference, that is 4 centimetres. Okay, we then have our area of our cross section, which is a circle this time, which is pi r squared. So that's pi multiplied by our radius, which is 4 squared. Okay, plug in that into your calculator. Again, I'll show you how to do that. So we have shift pi as shift, and then that's that button down here, multiplied by 4 squared. So you should get 16 pi, which is 50.265 centimetres squared. Okay, so the volume of our prism, back over here, is equal to the area of cross section multiplied by our length, as we've used a few times now, and the area of our cross section is 50.265, and the length, so that's the amount it's projected by, so the length that this is moved down by to get to this face is 15. Okay, 15 centimetres, and then if we multiply those together, you end up with 753.98 centimetres, and they're cubed because we're dealing with volume. That's not the end of this question though. It goes on to ask you, Jessica fills the vase from the tap. Water flows into the tap at a rate of 80 centimetres cubed per second. Jessica turns on the tap and fills the vase for 10 seconds. So for every second that she's got the tap on, it's filling up by 80 centimetres cubed. Okay, so if she has it on for 10 seconds, we have 10 lots of 80 centimetres cubed going in. Okay, so the volume of water is equal to the amount going in, so that's 80, and that's happening for 10 seconds, so we have 10 lots of 80 going in. Okay, so our answer for the volume of water is 800 centimetres cubed, because it is a volume of water. Okay, so if we poured 800 centimetres cubed of water into our cylinder, the volume of our cylinder is only 753.98. So 800 centimetres cubed is bigger than 753.98 centimetres cubed. Therefore, we can say that the vase would overflow. And that answers your question.